x's. So this is chapter 4, section 3. They want us to graph this function, but the negative puts that on the bottom, so we have that. Now, the denominator is never 0 because here is an e to the x function, looks like that. And actually, the bottom does approach 0 as we go to negative infinity. You see it's closer and closer to 0. So technically, as I move to negative infinity, that is going to cause this function to go really big. But we're not going to worry about that because we're limited from negative pi to pi. So I won't worry about what happens at the endpoints because that's not our concern. Okay, so no vertical asymptote in our domain. Let's find relative maxes, relative mins, increasing, decreasing, all that good stuff. So what tells us that? The derivative. I'm going to do, I have a choice. I could do quotient rule on that or product rule here. I'm guessing most of you did product rule, so I'm going to do product rule. So we leave the first alone and take the derivative of the second, plus we take the derivative of the first, but here's the problem, that's not t, so that becomes box. The derivative e to the box is e to the box times derivative of box, and we leave the second alone. Now we see we have a common denominator, or actually common factor. So I'm going to factor out e to the minus t because they both have one. That's going to leave me with cosine t minus sine t. And I'm going to rewrite that. The negative here is going to move that to the bottom. So I end up with cosine t minus sine t all over e to the t. Okay, so there's our derivative. What are the critical points? The critical points are the points where the derivative is 0 or does not exist. It'll be 0 when the numerator is 0. And it will be non-existent when the bottom is 0. But that never happens, so we can ignore that. So our critical points will be the top situation. Now you can do this logically. When is something minus something 0? When they're equal to each other. When is sine and cosine equal to each other? Well, on the unit circle, that was supposed to be a circle. Pi over 4, 45-degree angle, you get sine and cosine being the same. So here, 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 and here. But here, one's whoa, undo that. Here, cosine's negative and sine is positive. But if we have a negative and positive, they're not going to get 0. So you want them both positive or both negative. So this is going to occur here and here. So as we move around, this is going to be pi over 4. This is 5 pi over 4. But 5 pi over 4 is past pi, so we ignore that one. We don't need that one. But we're allowed to go to negative. So I can go backwards this way to get here. That's going to be negative 3 pi over 4. So that's going to be the two places. Now, how do you do this more analytically? I'm going to add sine to both sides. Let me move this over. I'm going to add sine to both sides to get cos t equals sine t. Now, I'm going to divide both sides by cosine. Why? Because I get 1 equal, sine over cosine is tangent t. So we ask ourselves, what angles has a tangent of 1? Well, pi over 4, we just had that. If we keep going, 5 pi over 4, but that's bigger than pi. But if we go backwards, negative 3 pi over 4. So we get the same answers either way. So those are our critical points. I'm going to have to drop this graph even lower. It's getting in the way. So we need to make a chart here. T and G prime. Left end is negative pi, right end is pi. Again, they told us that at the beginning. We have 2 critical points. A number between that, that's easy, 0. And a number bigger than that, I like pi over 2. That's definitely between these values. And negative 3 pi over 4 and negative pi, I'm going to go negative 5 pi over 6. Because that's a nice number I know between these two. All right, so we want to know what the derivative is on each of those regions because the derivative tells us increasing, decreasing, and relative maxes and relative mins. So let's do all of this. Let's do the easy one, 0. So let me plug in a 0 here and a 0 here. Cosine of 0 is 1. Sine of 0 is 0, so the top is 1. And e to the 1 is e. And 1 over e is a positive number. So I know it's positive at 0. I plugged in 0. Let's plug in pi over 2. Cosine of pi over 2, that's 0. Sine of pi over 2 is 1. So it's 0 minus 1 over e to the pi over 2. That's positive, that's negative. So we're going to have a negative in this region here. And then negative 5 pi over 6. If I put a negative 5 pi over 6 there and a negative 5 pi over 6 there, I'm going to get, it's going to be negative radical 3 over 2. And then the sign is going to be negative 1/2 all over e to the negative 5 pi over 6. Well, that's always positive. It's never negative. And these are both negative. So 2 negatives make an even bigger negative. So negative over positive is going to give me negative. You can pop those in your calculator, do it however you want, but that's what I get. And then I realize here I have a rel min. Why? Because the derivative changed from negative to positive. And at this point, I have a rel max. How do I know I have rel max? Because the derivative changed from positive to negative at that point. So I have decreasing, increasing, decreasing, rel min, rel max. So that tells me a lot about the graph. In fact, I want to find the value of the function at those points so I can graph it. So what's g at negative 3 pi over 4? And what's g at pi over 4? So we'd plug those values into the original, and we would get some values for that. So let me go ahead and get those y values for you. Instead of popping to a calculator, I'm just going to look at the answer in the book because I can do that. Let's see, what number are we doing? Is this 29 from 4-3? All right. So g at negative 3 pi over 4. Let me get the value for that. Hopefully they tell me. Yeah, that's going to be a crazy number. Negative radical 2 e to the 3 pi over 4 over 2. And at pi over 4, it's radical 2. I have to get an approximation for that. That's crazy. 2 e to the pi over 4. I'm surprised they don't give me an approximation for that. Well, I think they did. Yes, they did. So it's about 7.46. Negative 7.5, I'll say. And then the maximum point is about 0.322. 0.32. Okay? So that gives me the rel mix, rel min, and rel max. And I may as well graph at this point. I may as well do it. Okay? So on this graph, can I Let me plot some points here. Let me make this fatter then. Yeah, let's do this. Let's not mess around. Let's do this real. So let's go, every 2 is pi over 4. This could be pi over 4, pi over 2, 3 pi over 4, and this will be pi. And the same thing, this will be negative pi. So let's plot our relative max and min. So we have a relative min, or yeah, negative 3 pi over 4. So we're going to go negative 3 pi over 4 and down negative 7.5. Negative 3 pi over 4 down negative 7.5. Negative 3 pi over 4, 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, yeah. So that is a relative min. We just found it here. So I plotted that point. We have a relative max at pi over 4, 0.32. So let me graph that point. Pi over 4, 0.32. Wow, it's real small right there. So that's going to be our relative maximum point. So we have that. Now we kind of know the shape, kinda, but let's do a couple more pieces of thing. We need the concavity. So we're going to look at the second derivative now. So G prime, as a reminder, is this. There's a lot going on in this problem, a lot. So let's find the second derivative. We have a product rule, and I'm going to run out of room here very quickly. So let me do it down here. Product rule. I leave the first alone, and I take the derivative of the second. It's going to be minus sine t minus cos t, plus I take the derivative of the first, that's e to the box. So it's going to be e to the box times derivative of the box, and then I leave the second alone. I have a common factor of e to the minus t. I will take that out. And I'm left with minus sine t minus cos t. Distribute that minus. I'm going to get minus cos t plus sine t. And beautifully, these are going to cancel out. So when I distribute that, I get the plus here. And so all this to say the second derivative is minus 2 cos t all over e to the t. Because the negative exponent, it moved to the bottom. That's g double prime of x. Wow, I am running out of room here quickly. And this is taking a long time. So let's just keep going. So I found my second derivative. And now I find where it's 0 or undefined. So I'd set the numerator equal to 0 to find where this equals 0. Divide both sides by negative 2. So what angles is cosine 0? Well, pi over 2 in my unit circle, and then negative pi over 2, and that's going to be the extent for that. So it's going to be down here and here cosine 0. So positive pi over 2 and negative pi over 2. Then I have to find where this is undefined. But again, this denominator is never 0 because e to the t is never 0. So we don't have that. We only have 2 points. And again, we make another table. I am really against the space here. So hopefully you can follow my ugly work. So pick points in each region. 0 is easy. Between pi over 2, I'm going to do 3 pi over 4 and negative 3 pi over 4. And I'm going to test my second derivative. So cosine of 0, that's 1. That's going to be positive. So negative 2 over positive is going to be a negative. So we know is concave down in that region. 3 pi over 4. Cosine of 3 pi over 4, that's definitely negative because I'm in the second quadrant. Negative times negative is positive. Over positive is going to be a positive. So it's concave up to the right of pi over 2. And to the left of pi over 2, cosine of negative 3 pi over 4, that's in the third quadrant, that's negative. A negative and negative make positive. Over a positive is going to be positive. So we're going to have concave up, concave down, concave up. Okay, let's keep going. This is like tiring. We need to find out our endpoints. What happens at our endpoints to finish our graph off? What happens at negative pi and pi? So g at negative pi will be sine of negative pi is 0. That's easy. That's 0. And g of pi for the right endpoint, plug in pi, sine of pi is 0. That's easy. So we're at 0 at the left and right endpoints. So let me graph those. And this is all coming together nicely. Oh, wrong spot. It's 0 here, 0 here. We know this is a relative max, that's a relative min. So we're going to get something like that, kinda, right? But we have to take our concavity into consideration. So left of negative pi over 2 is concave up. So negative pi over 2, I'm going to label that. Oh, whoa, what was that? 1, 2. That's going to be negative pi over 2. So we know it's concave up in this region because that's what we found here. So we need to draw a curve that's concave up for that. So I'm going to do concave up. That's concave up. And we have our relative min there. I kind of messed it up, but that's pretty close. So that's that part. Then from negative pi over 2 to pi over 2 is concave down. Well, pi over 2 is right here. So in this region, we need concave down, but that's relative max. So we're going to be like concave down, but a relative max. We're going to look like that. And this is the inflection point where concave up meets concave down is our inflection point. So I'm going to do that. So it's going to look like that. I probably should have found my x-intercepts, and I'll come back to that. And then what happens? Oh no, I am confused. I am very confused because, oh, I know what's going on. I know what's going on. I messed up, and I'll tell you how I know I messed up. I'm concave up to the right here. Well, if I draw a concave up, something bad happens. Look. If I draw a concave up, I have another relative min. That's not possible because I only had 2 critical points. So that is a bad drawing. So here's what actually happens. Let me erase that and erase that. So I am concave down here. So here's what happens here. It still is concave down till we get to here. And then here it's concave up. So it's going to transition. So I'm kind of bad. This should be the max. So I should have gone down lower here and then curved back. But that's relatively close to what it looks like. So basically, this homework you're doing here is making sure you fully understand the ramifications of a second derivative positive negative, a first derivative positive negative, relative max, relative mins, and all that. The graphing, you're not going to have anything extensive like this on an AP test. But if you understood kind of everything I did, it kind of gives you a good idea of everything. Now, what I should have done is find x-intercepts and y-intercepts. I should have done that. And I will do that here. Let me erase this. And it helps us draw our graph. But I am just out of room all over in general, so let me erase a lot of stuff here. And I will cover that last thing. X-intercepts, Y-intercepts. Okay, how do you find X-intercepts? X-intercepts are where it crosses the X-axis. But on the X-axis, wherever it crosses, the Y value there is 0. So for X-intercepts, you set Y equal to 0. So you say 0 equals sine t over e to the t. So that means sine t must be 0. Where is sine 0? Sine is 0 on the unit circle, here and here. So that's going to be 0, negative pi, and pi. So I should cross at 0. Okay, so that tells me I should have crossed at 0, right? Do you see that? So this should be coming higher like that. So it's helping me to shape this graph. And then how do you find y-intercepts? That's even easier. To find a y-intercept, that's where a graph crosses the y-axis. But on the y-axis, x is 0. So to find that, I set x equal to 0, and I get g of 0 equals sine 0 over e to the 0, which is 0 over 1, 0. So the y-intercept's 0, but we already saw that. Bam. So that is everything in one problem.